Good afternoon. Thank you for coming to our presentations. Today we are going to discuss the challenging of bonding thermoplastic elastomer tubing to traditional connectors. And we're going to also talk about our solution to this difficult problem. We're going to talk about the TPE momentum in as a PVC alternatives. Our main discussion is really on why TPE bonding is so difficult. And we'll talk about our medalist bonding solution. PVC alternative momentum is really coming to a lot of public misconception, I would say. A lot of perception is not really science-based. You have some issues not really related to PVC, but the PVC gets the blame, such as lead in the toy, contaminated pet food in the pet food, or even toxic additive in toothpaste. But those have nothing to do with PVC, but the PVC gets the blame. Also, consumers tend to oversimplify the name. In PVC, we know PVC is really perfectly safe polymer, but the additive or the pesticide, the solid, has some safety concerns, and people, solid is difficult to pronounce or spell. And so they just blame it to PVC. So in the industry, people are looking for PVC alternatives, and many companies have R&D evaluations looking into PVC alternatives. Many company up management has strong support for PVC replacement, and you start to see non-PVC product advertised in the catalogs. However, PVC is a really, really good material, and it has a very successful history in medical device applications. And there has not been really a practical alternative for PVC until now. Teknor Apex is really uniquely suited for finding that alternatives. We have over 30 years experience in serving to the medical industries, and we are one of the largest global PVC compounders. And we have dedicated, focused TPE medical teams, and we are proactively working on searching the PVC alternatives. So for medical industry, we have traditional PVC, we have non-DEHP PVC, or we have non-solid PVC. And now we have a good, excellent alternative for PVC if PVC use is limited. We closely work with customers, listen to the voice of our customers, and we have developed a thermoplastic elastomer for medical application. This is our Medalist 500 series. The material feels like a PVC and has excellent clarity, very good kink resistance, and a lot of other good property like a PVC. One question people often ask is, many people know about the TPE. They know it's very difficult to bond. And today, we're going to address that question. Typical medical device, like a traditional infusion tubing, when it's connected to a female connector, if the size is 4 millimeter in out diameter and 2.5 millimeter ID. Typically, people want to have a retention force of 8 pounds or 35.6 Newton force. But in many applications, actually people request to have not only the average to meet that requirement, but with significantly high confidence, 99.7%, which means the average minus the 3 standard deviation has to be above their value. Now, PVC is very easy to bond to many engineering resin, just use solvent. And this is a strain retention curve of a PVC tubing on a connector. When you pull it, the stress goes, the retention force goes up high very quickly. However, for a TPE, if you same size of the tubing to the same connector, the retention force is not that high. And particularly as you see, if the tubing is made of a hardness below 85A, you get a very low retention force. By the way, the green line is 8 pounds or 35.6 threshold that people want. And if the hardness is 85 or above, then you can get to that force. But realistically, 98 hardness TPE is just too stiff to be used as a medical tubing. So it's very difficult. If you plot the hardness over the retention force, you can actually get a straight line. The harder the tubing is, the higher the retention force is. But realistically, in many applications, people want medical tubing made with hardness 75 or below. If you use that hardness, then it's very difficult to get to the retention force needed. In here, it shows basically only above 85A you can get to the retention force need. We also evaluated different commercial adhesive on the market, the retention force, and there are two popular adhesive. One is moisture-cured adhesive, and the other one is light-cured adhesive. Moisture-cured adhesive, some moisture-cured adhesive does give you very high retention force. However, the handle is difficult. Very often, on large-scale production, you don't have enough time to work with. So it's not really practical. People often resist to use them. Light-cured adhesive, on the other hand, because without light, it won't cure, so it has a lot. You have all the time you need to get a nice, clean-looking connection. However, the current light-cured adhesive does not give you the adhesion you need. So let's looking into why bonding TPE is so difficult. This is the structure of the thermoplastic TPE based on SEBS elastomer and polyolefin. Those two polymers are very inert. The surface has very low surface energy, and they are not easily soluble in common solvent at room temperature. In fact, you can't really find a good solvent to dissolve them at room temperature. So this kind of structure makes bonding very difficult. And so people start to look for solutions. Now, this is just one of the reasons. There is another bad news beyond that, and people may often overlook it. That's the physical mechanics of the material. Let's compare the tubing. When you pull the tubing of a PVC versus a TPE. For PVC, when you pull the tubing, the stress goes up very quickly. It will break at typically less than 200%. However, for TPE, when it's the same size of tubing, when you pull it, it stretches, and usually won't break until it reaches more than 10 times its original length. So it really it really stretches. Let's look at the common phenomenon we call poisson effect. When an elastic material is pulled, the perpendicular direction will shrink. So imagine in a tubing, if a tubing is pulled, the diameter will reduce. Now, common material, we'll talk about the Poisson ratio here. For wooden cork, when you pull a wooden cork or compress a wooden cork, the perpendicular direction actually does not change. So for wooden cork, the Poisson ratio is close to 0. But for elastic material, like a PVC or elastomer rubber, those materials have Poisson ratio around close to 0.5, so have significant stretch. But there's a big difference between PVC and TPE is PVC does not like to be stretched. So, even though it has similar Poisson ratio, when you stretch it, it doesn't really, the diameter does not reduce much. Here shows the tubing and the connector diagram. When the tubing is very rigid or made of a PVC, when you pull it, the diameter does not change. So this simple shear gives you a pretty good retention force. And in fact, the force along the interface between the connector and the tubing is pretty uniformly distributed. So you can get a really high retention force. When you do the same test on a flexible tubing, the tubing size diameter will significantly be reduced. That will give you some peeling force. So in a way, not simple shear force, you're peeling away from the wall of the connector. In addition, because it's more flexible, the tubing, the stress here between the connector and the tubing out diameter, they are not evenly distributed. That also makes it very difficult to get high retention force. Let's recap why it's so difficult to bond TPE. So that we know the commonly knowledge, the low surface energy, and very difficult to find a good solvent to bond. That's commonly known. And this is a lot of the people may overlook this Poisson effect. Now the good news is we have solution that people are looking for. And for room temperature, we have room temperature cured adhesive that we significantly improve the adhesion. In fact, this room temperature cured adhesive system we commonly refer as a TAC 3. It can lead you to cohesive failure, which means when you pull the tubing from connector, the tubing breaks rather than the tubing pulls out. We also developed a light cured adhesive system we refer as the TAC 4, and the retention force is higher than any other commercial light cured adhesive. Now, for some customer, maybe solvent bonding is the only system. Even that, we have a system for you. You can still use the common solvent. You don't even need to use multi-layer tubing extrusion. Of course, all those three bonding systems are pending, but we love to talk to you, if you are interested. This is a recap of the retention force. All three. I'm sorry, this screen is a little bit. Anyway, all three tubing bonding system, we can easily get retention force well above 35.6 Newton force. In fact, most of the bonding force is above 40. That's for 75 show A hardness tubing. The solvent bonding system is also in the similar range. Somehow the screen is truncated. As one example here, this is a room temperature cured adhesive system. With that adhesive, we can really get the bonding force very close to like a PVC, similar hardness. Even for 65A hardness tubing, you can get very high retention force. And in this particular case, the tubing normally breaks instead of the interface pulls apart. So now we have TPE tubing material MD500 series that has all the good property like a PVC. Now we have addressed the bonding issues. So we have 3 different type of bonding systems you can use. So come and talk to us. Let's recap. We know the bonding of TPE is very difficult, and many people asking us the question. We have worked hard and we come up with a solution. So this is something that we can work with the customer to provide the bonding strength they needed. So many people worked on this project. We have a special thanks to HDB Meds, which opened their state-of-the-art extrusion facility, let us making high-quality extrusion tubing for us to do the bonding for study. If you have any questions, you can visit us at booth 2233. Talk to any of us in the booth, and I'll be happy to answer your questions.